In our last module, what we discovered is that Nicolas Cage thinks that there are too many self-indulgent wieners in Los Angeles with too much bloody money. Ironically, his response to this is to try and differentiate himself in an even more exaggerated negative skew, the skew of people in that top 10%. That is, for him anyway, people who have really exotic and expensive cars. Now we want to turn our attention to a different topic. We want to turn our attention to measures of dispersion. Dispersion gives us information about the shape of the data by identifying the outer limits of its values. In other words, it provides an estimate of how spread out the data is. There are three common measures of dispersion: range, variance, and standard deviation. Range simply refers to the difference between the highest and lowest values. It thereby gives you the outer limits or outer edges of the data overall. We already know a little bit about the standard deviation, but we didn't know that the standard deviation is just the square root of the variance. Now, I'm not going to make you calculate either of those, though I will go through calculations of the variance. Both the standard deviation and the variance indicate the outer limits of likely values around the mathematical average or the mean, and this is why they played such an important role in our inferential statistics. So for population data, the variance is the average of the squared differences from the mean. That is the mathematical average. So in order to calculate the variance, you start off by subtracting the mean from each value, multiplying that number, mean subtracted by the value subtracted by the mean, by itself, adding them all together, and then dividing them by the total number of values. So suppose we have a population that has the following values: 1, 2, and 6. The mathematical average, or the mean, for those values is 3. We can then calculate the variance with that equation that starts right here. We take each value, subtract the mean, and square it. Then add that number to the others. So 1 minus 3 squared plus 2 minus 3 squared plus 6 minus 3 squared. That total will then be divided by the total number of data points, 3. That gives us 1 minus 3, 2, negative 2, squared, which is 2. 2 minus 3, 1 squared, which is 1. And 6 minus 3, 3 squared, which is 9. And that will give us 14 divided by 3 units squared. Now, there's some important things for us to notice about this. First of all, the units of variance are always squared units. And so they tend not to be very intuitive for people when they think about dispersion of the population. So our variance in this case is 4.67 units squared. So if it was number of cars had at the average household, it would be 4.67 cars squared. Number of ice cream cones eaten in a week during July, that would be 4.67 units squared. So because those units are very unintuitive, people tend to take the square root of the variance, in other words, calculate the standard deviation, which brings us back to units that we're more familiar with. Now, it's important to notice a couple of things as well. Both the variance and the standard deviations are estimates about how much higher or lower an average value will be above the mean. So they allow us to estimate how much of our data is centered around that mean value. What about inferring variance from our sample value? Well, variance is still the average of the squared differences from the mean. That is our mathematical average. But we fudge a little bit. To calculate the variance, we subtract the mean from each value, multiply that number by itself, add them together, and then divide by the number of values minus 1 to give us a more accurate estimate. So again, using those same values, if we're calculating out the variance for our sample, we take 1, subtract 3, and square it. We add that number to 2 minus 3 squared, and add that number to 6 minus 3 squared, and then we divide that total by 3 minus 2. In this case, that gives us 14 divided by 2 units squared, or 7 units squared. If we take our standard deviation by taking the square root of our variance, we get approximately 2.65 units. We've looked at 3 different measures of dispersion. We start off with the range. The range is calculated by subtracting the lowest value from the highest value. For that reason, the range will always be in the units of our data, and the range will likely contain or be a number that's a possible value for our data. The range will always be a positive number as well. Because we're only using these 2 outside points, range will be the most useful for us with small data sets. Variance and standard deviation are both measures of dispersion that are tied to the arithmetical average or mean. For this reason, they are estimates about how much variation you'll get from an average value in a given data point. Variance is also always going to be a positive number. The units of variance, however, are always going to be squared units, and hence not the units of our data set. Because both the variance and the standard deviation are tied to the mean, they may well be values that aren't possible values for our data set. Our standard deviation, however, will be in units of our data set. Like the variance, it will always be positive. So what else do we need to talk about? We still have 2 more topics, and we'll pick them up in the next lecture and module.